Salam and hello everyone. So today we're going to be working on the question on the screen that says um a vessel of volume 22.4 dm cube contains 2.0 mole of H2 gas and 1.0 mole of N2 gas at 273.15 Kelvin. So the first thing you have to do is to just basically write out what you're given. You've got the volume to be 22.4 dm cubed, which is the same thing as saying the volume is 22.4 liters because dm cubed, right, is also equal to liters. So I'm going to make this a column of its own, make another column. So you have this to be this. Then they told you the number of moles of H2 gas is 2.0 mole. So H2 gas is 2.0 mole, right? And the number of moles of N2 gas is 2, I apologize, is 1.0 mole. So I will need to write information out so no mistake whatsoever. And then you have the temperature to be 273.15 Kelvin. And you're asked to determine the mole fraction of each component. So what they're just trying to say is the mole fraction of each one of the gases, both the N2 gas and the H2 gas. So you have the mole fraction to be, the formula is the cursive X of, say, the H2 gas, which is the mole fraction of just basically mole fraction, okay, of H2 is going to be, the formula would be the number of moles of H2 gas in the mixture divided by the total number of moles of the mixture. So in total, so that's just simply us writing 2.0 mole divided by the adding the number of moles for both N2 gas and H2 gas. So that would be 1.0 mole plus 2.0 mole. And that's what you get. So that would just be the mole fraction of H2 would be 2 mole divided by 3 mole. And you cancel it out. And then what you end up with is 2 over 3, which is something as 0.667. Now we're going to replicate this for nitrogen gas. So N X2, that would be the number of moles of N2 gas divided by total number of moles, which is 1 mole of N2 gas divided by 3 mole, which is the total number of moles. So what you end up with is cancel, cancel. So that would be X N2 equals 1 over 3. Or you can just simply say X N2, so the mole fraction of nitrogen is 0.333. So that's it. And that's the answer. We've gotten that first one. Now, the second one, we're asked to find the partial pressures. Now, partial pressure is from the law of Dalton's law of partial pressures that just says the total number or total amount of pressure exerted in a mixture is just the sum of each individual gas component's pressures. So, like, say in this case, the total pressures in a mixture will just be the pressure of N2 gas as well as the pressure of H2 gas added together. So the sum of this pressure is going to give us the total pressure exerted by the mixture. So this is called Dalton's law of partial pressures. Now, that is what we need. So that means basically to find the total pressure or each one of these individual, we can use this formula. But there's also something else you need to know, right? Because it's chemistry. There's always something else to know. So you have the partial pressure, for example, of nitrogen divided by the total pressure of nitrogen is actually going to give you the mole fraction of nitrogen. So it's important for you to know that if we even want to find the mole fraction of nitrogen, we can just divide the partial pressure divided by total pressure. But since that is not the case here, where we are trying to find the partial pressure, so this is just going to be the partial pressure of nitrogen is going to equal X, so mole fraction of nitrogen times the partial, sorry, times the total pressure. And this is what we do. And we'll do this exact same thing too for hydrogen gas. So I just wanted you guys to know the importance of this formula because it's still going to come into play. Now, Because we don't know what the partial pressure is, we don't know what the total pressure is, we cannot move on, and we have to solve one of the two and combine it with the partial pressure of nitrogen to get the last one. But we don't know what it is, so we're just going to use the information we have. If we go back to our work, we see we have the volume, we see that we have the temperature, and we see that we have the total number of moles, which is the addition of the mole components amounts. So that means we can use the good old ideal gas formula, PV equals nRT, where in this case the P is the total pressure and the N, the number of moles, is the total number of moles. So what we actually have, rewriting this, is to find the total pressure, we have PT subscript equals in NT RT divided by V. So that is what we do. So the total pressure becomes the number of moles. We have that to be total number of moles, 3.0 mole, right? Times the gas constant, 0.08206 liters ATM divided by mole Kelvin times 273.15 Kelvin. So all of that information divided by the volume, which is just 22.4 liters. So we start off, I like to do this all the time, cancel out all of the units so I know what I'm working with. Mole cancel out, Kelvin cancel out, liters cancel out. So we only have ATM, which matches the fact that we're finding pressure. So that means we're on the right track. So I'm just going to rewrite what we have. So P total is just going to be 3.0 times 0.08206 8 times 273.15. Remember atmosphere, since that's the only unit that remains, divided by 22.4. So we input this in the calculator to get 3.00197 atmosphere. So P total will approximately be 3.0 atmospheres. So that means the total pressure, let me rewrite that. P total is just 3.0 atmospheres. Now that we have the total pressure, we can do what we would like to do to be able to get the answer. So we have the mole fraction. Looking at the formula I taught you previously, remember, you have the partial pressure of N2 is going to be the mole fraction, that is just how it works, of N2 times the total pressure. And then in this case, the partial pressure of H2, the second component, is the mole fraction of H2 times the total pressure. So we can use each one of this formula to get it. So let's use the partial pressure of H2. I like to use that, equals the mole fraction of H2 times PT. So that would be partial pressure of H2 is just going to be, the mole fraction of H2 is 0.667, like what we solved for right here. Okay, that times the total pressure, which we solved for to be 3.0 atmospheres. So what we end up with is pH2 equals, not times, I apologize, equals 2.0 atmospheres. And that is the answer to this one. The second one is just simply remembering that the total pressure, remember this formula here? Total pressure equals to the sum of the each individual pressure component. So PN2 plus pH2. So we can rewrite the formula to be PN2 equals, right, P total minus pH2. So that will give you P total, PN2 to be, P total is 3.0 atmosphere minus that of H2, which is 2.0 atmosphere. So the pressure of nitrogen, the partial pressure of nitrogen, is just 1.0 atmosphere. So now we have determined the mole fraction of each component successfully. We've determined the partial pressure and we've determined the total pressure. I wish you guys all the very best. Make sure you watch all the videos on this series for physical chemistry. The textbook I'm using is the Oxford Atkins Physical Chemistry book, the 11th edition. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh. Keep watching.